Breaking news. At 0342 UTC this morning, automated alert systems across NASA's Deep Space Network began triggering in rapid succession. Within seconds, telemetry streams from Mars orbiters, surface rovers, and ground-based observatories lit up control rooms from Pasadena to Darmstadt to Santiago. Engineers watched as the same impossible pattern unfolded across independent instruments. Today, the impossible just happened. Moments ago, mission controllers confirmed that the interstellar object known as 3I Atlas has released an unidentified payload directly into the Martian atmosphere. Not debris, not dust, not a natural plume, a controlled deployment. This changes everything we thought we knew. If you want real-time updates on the most mysterious cosmic events ever recorded, hit like, subscribe, and stay with us, because what you're about to hear is not speculation. It is data, and it is unprecedented. The confirmation did not come from a single sensor or a lone analyst staring too long on a noisy screen. It came from a convergence of humanity's most advanced scientific infrastructure. NASA's Deep Space Network first registered a sharp electromagnetic spike aligned with Mars's orbital longitude. Minutes later, ESA's European Space Network confirmed anomalous radar returns near the planet's upper atmosphere. Almost simultaneously, optical telescopes in northern Chile detected a transient glow above the Martian limb, brief, localized, and geometrically precise. At the Atacama Large Millimeter Array, technicians halted routine observations and pivoted every available dish toward Mars. At Caltech's Jet Propulsion Laboratory, senior scientists were pulled into emergency briefings before sunrise. At Harvard's Center for Astrophysics, simulations were paused mid-run as new parameters flooded in. The James Webb Space Telescope was quietly retasked to near-infrared bands between 1.2 and 4.8 microns. Hubble followed, cross-checking visible light scattering. Radio arrays in South Africa and Western Australia began sweeping for correlated emissions. This was not one instrument malfunctioning. This was consensus. The object known as 3I Atlas, first identified by its hyperbolic trajectory and excess velocity of nearly 42 kilometers per second relative to the Sun, has already rewritten our understanding of interstellar visitors. But now it has crossed a new threshold. It has interacted with a planet. 48 hours before the event, everything appeared normal. Orbital solutions showed 3I Atlas continuing its outbound arc, already past perihelion and accelerating away from the inner solar system. Distance from Mars was measured at approximately 0.19 astronomical units. Surface temperature estimates hovered near 210 Kelvin. Spectroscopy showed trace carbon compounds and water ice. No jets, no rotational instability, no warning. Then, 11 hours later, subtle anomalies began to appear. Tracking stations in Goldstone recorded a minor but statistically significant deviation in velocity, just 0.04 kilometers per second. Insignificant on its own, but Madrid and Canberra confirmed the same deviation within minutes. There was no detectable outgassing. Solar radiation pressure could not account for it. 6 hours after that, thermal imaging from Atacama revealed something stranger. Heat distribution across 3I Atlas became segmented, with discrete regions fluctuating by nearly 35 Kelvin in under 10 minutes. Instead of a smooth gradient, the surface appeared to reorganize itself into structured zones. No known natural process could produce such controlled thermal variance. 2 hours before the deployment, rotational data showed a sudden stabilization. Since discovery, 3I Atlas had been tumbling chaotically. Now, abruptly, its rotation aligned along a single axis. Angular momentum appeared to dissipate without measurable energy loss. Then came the moment that changed the conversation entirely.
At 0342 UTC, Mars Reconnaissance Orbiter detected a localized ionization bloom in the upper Martian atmosphere, centered roughly 140 kilometers above the planet's surface. Within seconds, Perseverance and Curiosity registered transient electromagnetic disturbances, tiny fluctuations measured in nanotesla, but synchronized across hundreds of kilometers. Simultaneously, orbital spectrometers observed a narrowband emission spike at 557.7 nanometers, excited oxygen atoms, followed by a rapid dispersion pattern consistent with a high-altitude release. And then, Perseverance's atmospheric sensors reported something unprecedented, a descending structure. Not a meteor, not a plasma streak, a coherent object, approximately 8 meters across, decelerating from hypersonic velocity to subsonic speeds in under 12 seconds, without producing a shock wave. No parachute, no heat shield, no known aero-braking profile. High-resolution imagery captured a faint, lattice-like silhouette before it vanished below the dust haze. The deployment had begun. Emergency calls were placed across agencies within minutes. Dr. Elena Moravec at ESA initiated a cross-planetary anomaly protocol. Dr. Jonathan Reyes at Caltech ordered immediate gravitational backtracking to confirm the trajectory origin. At MIT, computational physicists began modeling atmospheric interaction scenarios. None matched the data. As the hours passed, the anomalies escalated. 3 hours after the atmospheric event, radio telescopes detected repeating broadband emissions centered near 1.42 gigahertz, the hydrogen line. Not narrowband, not a message in any conventional sense, but structured, pulsing at intervals of 19 minutes, then 11 minutes, then 7. Prime number spacing. This was no longer random. It was responding. Spectral analysis showed the Martian upper atmosphere briefly enriched with ionized argon and xenon, elements not typically present at those altitudes in such concentrations. Thermal sensors recorded localized heating of nearly 120 Kelvin above baseline, confined to a circular region less than 30 kilometers wide. Gravitational modeling revealed a microperturbation in Mars's magnetotail, synchronized precisely with the pulse intervals. At Stanford, machine learning classifiers trained on millions of atmospheric events returned a null result. No analog, no precedent. 2 hypotheses began to crystallize. The first, the mainstream explanation, suggested that 3I Atlas is composed of exotic interstellar material capable of phase transitions under solar and planetary electromagnetic influence. According to this model, stored energy could be released in a controlled manner, ejecting a fragment that interacted chemically with Martian upper atmosphere. Proponents pointed to unknown interstellar chemistry, to physics not yet catalogued. But the second hypothesis was far more unsettling. It proposed that the release was not accidental, that 3I Atlas executed a targeted deployment, that the object altered its trajectory, stabilized its rotation, and released a structured payload at a precise moment in Mars's orbit. Dr. Marcus Hale of Harvard reportedly stated during a closed briefing, if this were occurring in a terrestrial context, we would call this a reconnaissance insertion. Then came the second wave. 17 hours after the atmospheric event, one of the faint radio sources associated with the deployment simply disappeared. Not faded, not drifted out of range, it vanished across optical, infrared, and radio bands simultaneously. No debris, no energy spike, no warning. The remaining emissions reorganized within minutes, locking into a new pattern with millisecond-level synchronization. At the same time, Earth felt subtle effects. Navigation satellites reported transient timing errors measured in nanoseconds. Radio blackouts flickered briefly over the South Pacific. Magnetometers in polar regions detected a small but coherent disturbance, less than live kilometers per second, harmless, yet perfectly aligned with the Martian pulse cycle. Inside control rooms, the atmosphere shifted from curiosity to silence. Encrypted channels multiplied, data releases slowed. Analysts noticed that certain datasets were quietly reclassified. World governments were briefed, not on conclusions, but on uncertainty. No one announced panic.
But no one dismissed it either. I remember staring at the data feed as the simulations updated in real time. The equations balanced, the graphs were smooth, and yet nothing about them felt reassuring. Because for the first time, we were not merely observing an interstellar object behaving strangely, we were witnessing coordinated activity across planetary distances. As days passed, the Martian atmospheric disturbance began to stabilize. Thermal output returned toward baseline. Radio pulses weakened but did not vanish. High-altitude spectrometers continued to detect trace anomalies, lingering like an echo. Meanwhile, 3I Atlas continued its silent journey outward, accelerating back into interstellar space. Its trajectory remained hyperbolic. It was not stopping. It was passing through. But it had left something behind. In the quiet moments that followed, reflection replaced urgency. For centuries, we believed that interstellar objects were passive relics, frozen debris drifting between stars. But what if some are more than that? What if intelligence, in some form, does not announce itself with grand signals, but with subtle interactions? Maybe we are not witnessing the end of certainty. Maybe we are witnessing an invitation. Mars has always been a mirror for humanity's hopes and questions. Now it may also be a crossroads. As instruments remain locked on both the departing object and the altered Martian skies, every pulse is logged, every fluctuation is analyzed, every deviation from expectation is cataloged. The data keeps coming, the questions keep growing, and one thought refuses to fade. If 3I Atlas could deploy something into the Martian atmosphere once, what happens when it does it again? Subscribe to follow the next update, because the story of 3I Atlas is far from over.